welcome back. Let's continue with linear correlation coefficient and also Pearson's product moment correlation coefficient. Okay, so before this, you have learned on how to construct the scatter diagram, and from the scatter diagram, you will describe the relationship between two variables, whether it is positive or negative relationship. Okay, for linear correlation coefficient, it provides us with the measures to evaluate the strength of the relationship. Okay, let's say if you have a positive relationship, okay, the positive relationship, it can be perfect positive relationship, it can be a strong positive relationship, or it can be weak positive relationship. So how to know, how to identify, how to evaluate the strength of this relationship? By finding the value of linear correlation coefficient. Okay, value of correlation coefficient is ranging from -1 to 1. So this means you cannot have value that is more than 1 or less than -1 for your correlation coefficient. The value of correlation coefficient always from -1 to +1 only. Okay. There are two methods to calculate correlation coefficient. The first one is by using Pearson's product moment correlation coefficient method. Secondly, by using Spearman's rank correlation coefficient. Okay. By the way, for the second method, we will not discuss here because this one is not in your syllabus. So we will only discuss on the first method to find the value of correlation coefficient. The first method is known as the method of Pearson's product moment. Okay. So for correlation coefficient using Pearson's product moment, it is denoted by the symbol R. So R here is the correlation coefficient using Pearson's product moment formula. Okay. And this R is used to measure the strength. Okay, like I said before, correlation coefficient is used to measure the strength of relationship between the two variables that are in quantitative in nature. Okay, and R value, because this is correlation coefficient, R value only ranging from -1 to 1. Okay. Okay, after you find out the value of R, you must interpret this R value. The interpretation of the R value is needed to know the strength of the relationship. Okay. The sign for R, okay, the sign whether negative or positive, identifies the kind of relationship between the two variables. Let's say your R value is positive 0.5. So this means the two variables have a positive relationship. But let's say the R value is negative 0.2 because negative sign there. So this means the two variables have negative relationship. So the sign will indicate the relationship, the kind of relationship, whether it is positive or negative. But the magnitude of R will describe the strength of the relationship. Okay, so the magnitude here means the value of that R. So the magnitude will describe the strength, whether it is strong, weak, or moderate. Okay. Alright. Okay, this is the summary of the interpretation of the value of R. Okay. Please remember that R value is always from -1 to 1 only. Okay. And in the middle, we have the 0 value. So when your R value, when the correlation coefficient is 0, this means there is no linear relationship. There is no correlation. Okay. No correlation between the two variables. Okay. So when R is 0, no relationship, no correlation. Okay. When the value of R is +1. Okay. So this means the two variables having a perfect positive relationship. Okay. But if your R value from 0.9 until 1, it is still positive relationship, but this one is not perfect positive because it is not 1. So if your R value from here, from 0.9 until 1, so this means it is a very strong positive relationship. Okay. But if your R value from 0.8 until 0.9, okay, so this one means strong positive relationship. But if your R value from 0.5 until less than 0.8, so this one is considered as moderate positive. Okay. Okay, and lastly, if your R value is more than 0 but less than 0.5, let's say your R value is 0.4, so you can interpret that as weak positive relationship. Okay, remember the sign will indicate the kind of relationship, whether it is positive or negative, but the magnitude, the value will describe the strength of the relationship, whether weak positive, strong positive, or perfect positive. Okay, if let's say the R value is 0.93, this one is a positive value. So positive means positive relationship. Okay, now for the strength of the relationship, okay, so 0.93 is in this range here. So the relationship is very strong positive relationship between the variables x and y. Okay, now let's look at the negative relationship. So when your R value is negative 1, exactly negative 1, so you can say that the relationship is a perfect negative because the value is negative 1, exactly negative 1. Okay, but if the R value, it is more than negative 1, but it is less than or equals to negative 0.1, 0.9. So let's say R is negative 0.935. So this one is a very strong negative relationship. Okay, next, when your R value is more than negative 0.9, but less than or equals to negative 0.8. Okay, this one is considered as strong negative. Okay, next, when your R value more than negative 0.8 until negative 0.5, so this one is considered as moderate negative. But if your R value, it is more than negative 0.5 but less than 0, so this one is considered as weak negative. Okay, let's say your R value is negative 0.6. Okay, how to describe the relationship between two variables? Okay, negative here indicate it is negative relationship or negative correlation. Okay, how to describe the strength? By looking at the magnitude or the value here, the number here. So negative 0.6 is located in this range, this one. So it is moderate negative. Okay. All right. Okay, next, how to find the value of R? Okay, to find the value of R, we will use the Pearson's product moment correlation coefficient formula. So this is the formula. Okay, for R value, we have the n term here. N refers to the number of observation, and then we have this summation xy. Xy means x, variable x multiplied with variable y. After that, you find the summation value. Okay, and then we have the total x square down here. Okay, So this means you need to find the x square first, okay, and then find the total of x square. Alright, and one more thing, please be careful when using this formula. Total x square here is not the same as this. Total x square means the total of x square. The total of squares for every values of x. But this one, total x square, means the total x value. Let's say the total x is 100. So 100 value, you square it. Okay. So please be careful, especially with this part here. Alright. Okay, let's try this example. Okay. The table below shows the scores of 6 students in stats and mathematics tests. Calculate Pearson's product moment correlation coefficient for the following set of data and interpret your answer. Okay, for correlation coefficient, you must have the variable x and y. So for this one, normally in the table, the first row is the x value, the second row is the y value. Okay, so now you need to calculate the Pearson's product moment correlation coefficient. You need to find out the R value. So how to find the R value? Using this formula here. Okay, so in this formula, you must have the total xy, total x square, okay, and then we have the total y square also, this one total y square. Alright, so from this table, okay, this is the original table from your from the question x and y. So in your table, please add another column, okay, for xy, x square and y square. Xy means x multiplied with y. For example, 80 multiplied with 50. Then for x square, you just square the value of x. For example, 80 square. For y square, this y you square it. For example, 50 square. Okay. After that, find the sum for every column. Find the total for every column. Okay, next step, substitute all values into the formula. This R formula, we have n here. Okay, n here refers to the number of observation. So for the observation, we have 1, 2, 3, 4, 5, 6. 6 observations. So n is 6. 6. Okay, so this one is total xy. So this is the column of xy. Total xy is 23280. Alright. Next, we have minus total x multiplied with total y. Total x is 373. Total y is 365. Okay, this one and this one. And then we have divided by. Okay, so in this formula, we have the square root. The big square root here. Okay, so square root. Okay, first bracket, n is 6. Multiply with total x square. Total x square is this column, 24829. And then we have minus total x square. So total x is 373. So we need to square it. 373 square. Close bracket. Okay. Sorry, this one is supposed to be multiplied, not minus. Okay. Typo here. Multiply with, okay, bracket. And again, and is 6. Okay. Multiply with total y square. Total y square is this one, 23325 minus total y square. Total y is 365. Okay, so 365 square. Okay, and then simplify your answer. You will get something like this. So this is the final value. Okay, after that, you must give a comment on this R value. So this 0.4 means there is a weak positive linear relationship between scores of statistics and mathematics. Okay, this is the manual way on how to find the value of R. Okay, actually you can use your scientific calculator. It is much easier if you if you use the scientific calculator. So I will show you on the next video on how to use scientific calculator to find the value of R.